Hey everyone, it's Darren. Welcome. Have you ever wondered just how big or just how small Excel numbers can actually get? Well, it's pretty impressive, really. They can get pretty huge, but there are some limitations, and believe it or not, you might actually run into some of those limitations. So up here on the screen, I do have the official numbers from Microsoft. It's for the newest versions of Excel. Uh, And these are the numbers, these are the largest and smallest numbers, positive and negative, which Excel can represent. So your largest positive number that you can type in is 9.9999999999, whatever, to the e plus 307. If you have never done much chemistry or physics, you probably don't recognize that notation. That's called scientific notation. So let's just do a quick tangent over here to explain what scientific notation really is. Uh, Here I have some numbers that you probably do recognize. So we're going to take these, we're just going to copy them over here. And then we're going to change this format. This is a standard format, it's available in Excel. And let me go ahead and push this out a bit. So if you look here, all of these come out to 1.0000000, lots of zeros, e plus something, or e minus something. Actually change this format a little bit more to make this a little bit easier to read. It's going to take it down to one decimal place. And what this means is you do the part to the left is always your first digit. And then, so it's first digit point, the rest of your digits. And then you have E plus 00 in this case, which means you don't move the decimal. 10 is 1.0 E plus 01. Well, what is that? Well, all you're doing is you're saying, okay, so I have 1 as the last part of the number here. So I'm going to move the decimal place one spot over to the right, which makes it bigger. 1.0 e plus 02 tells me to move the decimal two places. So 1, move it over two places, gives me 100. Three places, four places, five places. And this obviously lets you get really, really big numbers. When you're talking about, as I mentioned, chemistry and physics, if you're talking about chemical reactions, you might need to know how many carbon atoms do I have that I'm working with. And you're not working with 10 carbon atoms, you're working with, some huge number. You know, billions, trillions, quadrillions of carbon atoms. And you need to know how many you have. So this is how you get to that. Uh, what about really small? Well, same thing. If the number after the E is negative, instead of moving the decimal over to the right, you move the decimal over to the left. So 1e minus 1 is zero point 0.1. You just move the decimal one place. 1e minus 2, move the decimal two places, and that gives you zero point zero 0.01. And with this scientific notation, you can represent pretty much any number of any size, huge, small, whatever. And the reason people use it is it's a lot easier. A lot of times, if you're working with the number of hydrogen atoms in the sun, which is in the quintillions. Uh, that is to the what 16th, I think. Uh, so those are kinds of the numbers that you're looking at. And my bank account isn't there. Your bank account probably is, of course, but I'm not there. But these are useful to know. And then when we come over here and look at what these largest numbers are, so the largest positive integer here we see is a whole bunch of nines, e plus 307. What does that mean? It means you have those nines, and then you move the decimal 307 places over to your right, which makes a really huge number. You'll notice that the largest possible number via formula is actually about twice that. You can't type in that number and have it work, but you can actually get there with a formula. About the largest negative number. Well, it's the same as the largest positive number, just the sign is different. And the largest negative number via formula, again, same as the largest positive number via formula, it's just negative. Uh, what about the smallest positive number, the tiniest decimal on here? And you see, so that first one, those other numbers I had like 15 digits out there. Uh, Here I only have 2.2251, and that's all the digits I get. Uh, and that's to the negative 308, which means I have 306 zeros in front of that. Uh, and the same with the smallest negative number down here, I have 306 zeros in front of that as well. Really tiny numbers. Uh, Probably you're not using those numbers so much. You you could sort of maybe bump into them if you're doing something really bizarre, like if you're counting the number of hydrogen atoms in the sun, you won't. Um, but if you're counting, oh, I don't even know what you'd use to hit that. Um, so you're probably pretty safe for that, and you're thinking there's no issue, and I'll never hit these numbers, and you're probably wrong. And the reason is because of this last little note down here on the Microsoft specifications for Excel. It only stores 15 digits. And only storing 15 digits, you might actually run into a problem. Depending on what you're doing, you can end up losing precision. You can wind up losing data off the end. If you have 15 digits is 999 trillion, 999 billion, 999 million, 999,000, and 999. If you add 2 to that, you should get 1 quadrillion and 1, except it can't track that last number. So you get 1 quadrillion. Uh, Probably you don't care. Probably you don't need that many digits of precision until you do. So if this is your bank account and you're thinking, well, I have 999 trillion something. Well, except you're tracking cents also, so you really only have 9 trillion, 999 billion, 999, whatever, and 99 cents. Because the more you put into the decimals, you have to keep going back on one side to extend on the other. And if you get bigger, you have to lose digits in there as well. So in this case, it looks like that those nines might go forever. They don't. They stop right there. So this is where you run into potential issues is if you actually care about more than 15 digits, because you can't do more than 15 digits. Um, you can cheat. There are ways of cheating to get around it. You can separate, you can run two separate numbers. You have your big number and your little number. In calculations, that's where you're more likely to care. And let me show you how you do it in calculations. So here we have 15 nines. And that's the most digits Excel is capable of showing us. And now let's play with this a little bit and see what sort of weird things we can run into. So if we do A1 plus 0.4, okay, we have that last digit there you'd think would have gone up to 0.4, but it didn't. It's still 999,999, whatever, 0.0. Okay, what about do that again? So we'll do A2 plus 0.4. And now it rolled over, even though it should be all those nines in a 0.8, but it rolled it up to the next digit. Um, what if we do equals A2 minus A1? and it gives us 0, even though somehow we added zero point 0.4 to A2 and got it to roll over, and A1 and A2 don't equal each other now. Uh, so this is kind of weird. And if we add uh, to A3, so we'll do A3 plus 1, it didn't do anything. Okay, so what's going on here with some of these weird numbers? So if I do A2 plus 0.04, A2 is just all nines and a 0.0. That should give me all nines and a 0.4. Up here we saw that all nines plus 0.4 came up with a 0. You'd expect it to do the same thing, and it didn't. It actually added 1. And at this point, this last digit over here doesn't work anymore, as we saw here when we tried to add 1 to it, and it doesn't display the 1. Uh, so when you get up over 15 digits, you hit 15 digits of accuracy, you start to lose stuff. This is whether you're working big or small. It doesn't matter if we have all 15 digits to the left of the decimal or all 15 digits to the right of the decimal. You're going to lose precision, and may or may not matter depending on what you're doing. If you care about it, if that level of precision matters to you, uh, one thing to keep in mind is to do all of your calculations on your small bits and then apply them to the big bits. If you're uh, doing 10,000 different small numbers, adding them together, and then adding it to the big one, if you add up those 10,000 first into a single number, and then you apply that to the big one, you have a better chance of maintaining your precision. Uh, doesn't always work, as you saw here. Um, Excel sometimes will go back through your original values and subtract them, and that's a mess. Uh, if you use parentheses, it'll always do your calculations in the order you tell it to do them in, so that works. But just be aware if your numbers look like they're starting to fall apart, if you're losing precision, this might be the key to what your problem is. Solving it is a lot more difficult, I'm afraid. I would say that you are extremely unlikely to ever run into any of those numbers. Those numbers are just so huge. I can't even imagine a way that you'd run into it. Uh, so I mentioned the number of hydrogen atoms in the sun is actually you'd need I think it's 18 digits to represent it. Uh, this number you might run into. So just keep an eye out for it. So any questions, leave them down in the comments. If you've enjoyed the video, hit like and subscribe and share this with your friends. Patreon page over at patreon.com/data analysis excellence. And I look forward to seeing you next time.